Okay, so today we're looking at horizontal dilations of the functions. Still with the same learning intention, where we're looking at gaining an understanding or building our knowledge of the order in which transformations and dilations are applied to a parent function and the way it will look. So here, we're really going to be looking at identifying and apply the function of f of x, and we get y equals f a of x. And when we have this situation, it's going to stretch the curve horizontally along the x-axis by a scale factor of 1 over a. Yeah, so if we get f a of x, we've got a scale factor of 1 over a. If a is bigger than 1, the graph is compressed. If a is between 0 and 1, the graph is stretched. If you get y equals f negative a of x, is a reflection in the y-axis. So let's show some examples. So let's start with y equals x squared. Okay, so that's our parent function. What we're going to do, so that's our y equals f of x. We want y equals a of x. Let's do 3x all squared. Okay, so there's your blue, that's your parent function first, and now that's f of x. Now this is f a of x. A is 3. Okay, here is our point 1 of 1. Yep, it has now changed its value. Maybe I'll zoom. Yep, there's your point 1 of 1. It's now changed the value to negative 9. Yeah, so there's a scale factor of a third. Okay. If obviously we change that to, let's say, 1 over 3, yeah, it compresses. And then we're talking about the horizontal. Not the vertical, so we're looking at the horizontal part. Okay, so there's your function. If we have a third, it compresses, it's moved it across. Okay. All right. Back here. So f of negative a of x is a reflection of the y-axis. I'll show you that one. So if we have negative a of x, because this is an even function, looks the same. We'll change it to y equals x cubed. Yep. If we get y equals negative x cubed, it's translated along the y-axis. If we have 3, okay, so there's your point, 1, 1, yeah. Because we have a 3, we're translating it across, so it's a third of that value there. Yeah, so the x changes, not the y. Right. So that's why you get a scale factor of a third. It's a third of this size. So we're looking at the vertical translation here. All right, so we want to complete the table below using the graph and scrap. Okay, so yeah, x cubed. All right, so yep. So if we're going to cube things, it's going to be 0, 1, 8, 27, negative 1, negative 8, negative 27. Okay, using the numbers here, we've got a quarter times negative 3, and then we're going to cube it. Okay, so negative 27 over 64. All right, let's do it with 2. We get negative 1/8. We get negative 1/64. Still get the 0 here. That should be 1/64, 1/8, and then 27/64. All right, and using the graph, so once again, there's the blue one is the parent graph. And we're moving this value from 1 to 1/64 because we're compressing it, making it flatter. Okay. So describe the translation that the constant makes of f of x equals x to the power of 5 and state the scale factor. Okay. So here the scale factor is 1/8. Yep. So it's 1 over a. Remember the scale factor is 1 over a. Yeah. And so it's that's between 0 and 1. So this compresses the parent graph along the x-axis. Okay. Here we get a reflection. So k is now -1. Yeah. So it's a reflection around the y-axis, but the size stays the same. Yeah. All right. Describe whether the constants describes a horizontal or vertical dilation. Okay. So here we have, so there's your function y equals f of x. This is y equals k f of x. Yep, because there's your x cubed. Yep. Because the k is on the outside, this is going to be a vertical dilation. Yeah, a stretch or shrunk up and down the y-axis. And the scale factor would be 4. Okay. Here we have, this is like writing y equals f, which variable do I use? 1 over k, or 1 over a, x cubed. Yeah. So because on the inside of the brackets, this is going to be a horizontal dilation. And the scale factor here would be multiplying by 5. Yeah, because of 1 over a. Once again, this is going to be a horizontal dilation. Yep. And the scale factor in this situation would be 2. Okay. If we have a point -2, 5, it lies on the function. We want to find the coordinate of the image of P of f of a of x given a equals 2. Okay. So here, remember with the scale factor, we really want is actually going to multiply the x value by 1 over a. So in this situation, it's going to be -1, 5. Yeah. we take our x value, we're going to multiply by its scale factor. So if it's a third, it becomes 3. So the new point would become -6, 5. Here we have, we're going to multiply it by -4. So it becomes +8, 5. Yeah, so this is a change in the x value through multiplication. Okay, and that's it. So when you have a function y equals f of x, and you put in y equals fa of x, well, this stretches the curve horizontally along the x-axis. So if a is greater than 1, then it's compressed because the scale factor is 1 over a. If a is between 0 and 1, the graph is stretched because it becomes a positive, or a whole integer. So y equals f of negative a of x is a reflection about the y-axis. Okay, thank you.